Morning, everyone. I represented our team to report to you the theme-based research scheme, the long title, but it's for diagnosis and prognosis. That means, to find what is going on and what will happen, for what? For eutrophication and hypoxia consequence in Hong Kong water and Great Bay water, oceanic water I'm talking about. I'm the project coordinator, and this project is participated by 7 universities from Hong Kong as well as from mainland. The nature of the study crossed the border because the ocean connected both sides. We needed the mainland side to get the data. My talk will include 3 parts: challenge, mission, achievement, like a traffic light. Okay, I will go through red, yellow, and the green. And our project in short name is called Ocean HK. Well, the first one, challenge. Challenge is hypoxia, eutrophication, and ecosystem consequence. Reach an alarming level. This is not just try to scare you. There's evidence going to report to you from this project. Well, the first one, the fact, Hong Kong, oceanic water. Hong Kong has its own oceanic water. But this water obviously cannot be separated from neighboring the oceans, such as Pearl River estuary, such as open ocean. So it is greatly affected by not only local, but also the remote. This particularly in Pearl River discharge. And Pearl River estuary. Estuary is the coastal embankment linked with the river on the land side and with the open water, open ocean in the seaside. Well, the fact is Hong Kong has 12,000 kilometers coastline, and its land area, its oceanic area, is much larger than the land area. Well, you live in Hong Kong, we all know this. And economic-wise, and also the other aspect, fishery industrial alone, just estimated from AFCD 2021, 2.8 billion. This is 122 million. Okay, it's aquaculture. Well, we are not that big, but it's substantial as well. We also have a traditional maritime industrial. This is huge. In Hong Kong, we have a very important maritime industrial. Well, and also related to coastal infrastructure, recreation, tourism, and this is just give you a glimpse of how busy Hong Kong waters is, our importance. Well, what is the problem? The problem is 2014, we went out to do the field survey. Now, it's very rare that Hong Kong that doing this kind of large-scale field survey. Large-scale, I'm talking about physical and biochemical together. That we found that just southwest of the Lantau Island and also south of Lantau Island, there is a pool of the low oxygen water. This low oxygen water has a concentration, DO, dissolved oxygen, less than 2 milligrams per liter. That means that it is a dead zone because organisms, the fish cannot breathe, and it will wipe out the organism and fish in the water, just in this area. This is 2014. Not even started this project. And then we went over there, 2015, we found that actually quite consistently that not only in the western part that we found in 2014, but also in western part, just south of the Macau, Zhuhai. So it linked together in the area between the Pearl River estuary and open ocean. We call it the CTG zone, transitional zone. Now, with the two relatively higher, the low oxygen center, one is in western side, of course, of Macau. Another one is of our Lantau Island. We did it again, 2017, when this project started. We also consistently found that the pair of the hypoxia water in the bottom landed in the CTG zone, and 2018. I show you more, okay? So obviously, there's a persistent large-scale eutrophication in hypoxia. That's what I told you, that we reach the alarming level. This is every year recurring. What is the consequence? We care. Why we care? Because eutrophication would lead to red tide, okay? And this is, I get it from CNN on the web, and then the massive scale of the death of the fish, okay? This, and I will tell you more consequence. We not only did the cruise on the 4 years, we did it actually for 20 cruises. This is the most remarkable the cruises in the region, and we are the most active, not one of the most. We are the most active team in entire the region, including the Greater Bay area, mainland water, and Hong Kong water. I think the Hong Kong first time that we can play this kind of dominant role in the regional ocean environmental research. And during all this cruise, we then calculated the frequency of hypoxia. This is a percentage of frequency. Okay, and you see, again, the most frequently occurred hypoxia again in this region, just in, again, CTG zone. Meanwhile, at the surface, you can see that like we have a higher the chlorophyll. That means surface you have eutrophication. Okay, now it's always in this circle, in this region, in CTG zone, which is bad news to Hong Kong, bad news to Macau, and actually even the western side that can be carried by current towards us. Double, the effect. We have local effect, we can have this effect, also western effect. Let's see the Hong Kong waters alone. This is the EPD water data, and you see that from 86 to 2016, we have an increase of the nitrate in organic, dissolved in organic nitrogen. It keeps increasing, while the temperature, of course, is increasing. We know the warming. DO overall is decreasing, okay? And the worst part is hypoxia, means the minimum, the lower the oxygen is also decreasing to very low. You see the 2 is here, and it's quite low. While our chlorophyll is increased. Chlorophyll means the potential to eutrophication, the increase. Okay, this is the Hong Kong data alone. So it's consistent with this kind of the survey. We look at the ocean, and we found that maybe, it looks beautiful blue, but this data tells you that may not be the case. Well, people here maybe know that we have a HATS, Harbor Area Treatment Scheme. Many people know that. We spend hundreds of millions dollars to clean up the harbor, okay? Now, if you take all the data here, this is again in Victoria Harbor. Then you see that those are the points, the dot, the circle are the data. You do the mathematical trend, the linear regression, well, it is our oxygen is increasing. Beautiful. Everyone happy? Okay. But if you look at, this is a trick. When you do the trend, be careful when you treat the data. Now, if you take the data trend, you see that this data obviously shows the 2 trends. One trend is before the HAS, which increased the oxygen, bottom oxygen. But after HAS, it's actually decreasing. Okay, so obvious. So we spend hundreds of millions of dollars, it's less sustainable. If you go, this is 2016, and you go down here, okay, is that alarming level? Well, we care, hypoxia or not, in Victoria Harbour, it does, because it will make the full odor due to the decomposition of the organic substance. If we don't treat that, sooner or later, our Victoria Harbour will be a problem, likely, potentially. All right. First time I show this one in public. We have Tomorrowland project. We're going to reclaim this island, okay? And if you, after reclamation, how do we know? You need to do the, this kind of the numerical modeling, and you got to do it right. And well, here the artificial islands, once you do that, well, you have oxygen. This is the oxygen, the concentration in the surface. In the bottom, you see the, as we showed before, the Lanto Islands, this is the airport here. South Lanto Island, we have low oxygen. The artificial island is here. If you use the future one minus current one, what happens? Net change. Net change is surface oxygen decrease and bottom oxygen likely decrease. Once this decrease, it will potentially increase the hypoxia, chance of hypoxia, and likely, well, it's already quite low. This is already low, okay? The previous picture, not this one, this is after reclamation. So if we build the island and we block the nutrient pathway here, we increase the residence time for those organic matter to grow, organic subspecies to grow, we likely generate the eutrophication and hypoxia. Okay, I know the government is doing this, and I can only say that this is, I don't have a project there. All right, the mission. What is the mission of this project? There's two missions. Number one, as a scientist, we understand what is the status now, what is the cause, of course, scientific mechanism, and what is the consequence. And after this, what will be happening? What is strength, okay? Number two, hopefully we can derive it, some kind of strategy, and this strategy got to be cost-effective, that means implementable to the water treatment protection scheme and so on, okay, in the region. Of course, got to be built on the first one to understand it. This project then built it on the 4 tasks. The problem we are dealing with actually is an oceanography problem. Oceanography to Hong Kong is relatively new, but not to the world. We need to use the oceanography because it's an ocean problem. There's a discipline called oceanography. And this oceanography is interdisciplinary, chemical, biological, and physical, and they are linked together. Interlinked with those areas. Of course, it is also related to marine ecology. Okay, this marine ecology is our Hong Kong that we have a quite large team and quite a long strength. Well, this project, besides these 4 PIs, we also have, the PCOIs and international expert collaborators from Woods-Hole Institute, from UCLA. Now, let me first tell you what is the project from hypothesis to solution. Hypothesis, well, if you see this animation, Hong Kong is here, Guangzhou is here, Pearl River, the water discharge onto the big area here, okay, while the oceanic water flow the salt water below. Now, this nutrient or dissolved in organic substance is bringing it towards the Hong Kong water, and in this region, because we have light. Here, you don't have light. And here has a particular hydrodynamic condition, therefore, eutrophication occurs. That means phytoplankton bloom occurred there, okay? And once this organic matter form, they die, they sink to the bottom, decompose, they suck in the oxygen. This is quite straightforward, or not quite straightforward, because you need to know the moving thing. That's called the circulation, ocean circulation. Okay, this our circulation not only related to the river, but also related to wind-driven current here. Let me, time constrained, so let me give you 3 remarks. The first remarks we have, this is a hazard, eutrophication hypoxia. I already showed you. The second one, in Hong Kong and GBA, this kind of the hazard is persistent and increasing, and this may or could offset the environmental improvement achieved through the costly harbor area treatment scheme. We spend so much money, we don't maintain it. It's like building, you build it, you need to maintain it. Okay. This project, Ocean HK project, we explain the how, where, and when, and we try to predict the trends, future trends. All right, the approach. You need to do the field measurement. Okay, as I said, this is a new skill and capability we develop. And then you need to have a numerical model because this one cannot be 24/7, cannot be every place. So you need this data. You then use your science to develop a numerical model, and then you do the synthesis. This is from this way up, down, and then you again the bottom up. Go back here, find a problem, observation, and again repeat the cycle. Okay, this is right approach of the research. You don't just go over there and take the blind people touch the elephant. And, but we did it, the whole picture, okay? Achievement. The first one, we tell you that, W4, where, when, why, and what else? What else means everything, others, and we tell you the I, impact, okay? Well, I showed you before. This is the hypoxia area. It is located in the region between the Pearl River estuary and the oceanic water. Or call it the coastal transition zone. And the total area is 600, close to 800 kilometers square. It's not a small area. And when? Well, this is one of the very, why I say, important part. This occurred every summer, of course. And people go there to do the survey. Someone go, oh, I don't see it. Oh, I didn't see it. Well, if you see this red curve, this is hypoxia in oxygen less than 2. Sometimes it's there in this location, buoy. Okay, it is says lower one, stronger one, lower one, stronger one. Although it consistently, persistently located in this zone, okay, hypoxia, but it has a special temporal variation. This temporal variation related to water stability, wind, river discharge, and many physical and biochemical processes. But overall, you average persistently, they occurred here. But each location, you have different. This is first this kind of buoy set up by us in this region. Okay, not even China, mainland has this kind of one. Why? Why is it here? Well, people sitting here maybe also will keep asking, why is sitting here? Why the hypoxia has to be here? They related to, of course, the nutrient discharge here. But nutrient discharge can be everywhere. Why not here? Why not other places? Well, related to those arrows. Those arrows are hydrodynamics. Those hydrodynamics is, one is called estuarine circulation, means the fresh water coming down due to the buoyancy force, push towards the ocean, and over the ocean here, we have a wind treatment, we have monsoon. They merge each other, they converge each other, and in these two regions where we find the lowest hypoxia, lowest DO, they formed this kind of anti-clockwise, or we call it cyclonic circulation. And this kind of the cyclonic circulation would let what? Concentrate the organic matter, concentrate the nutrient, provided longer residence time for eutrophication occurred in the surface and hypoxia occurred at the bottom. So here, biochemical process are necessary conditions. It's only necessary, and you also need to have a hydrodynamic condition. Two together, it combines, provided sufficient condition of hypoxia in the CDG. I think that this is the one that tell the community, tell us that the hypoxia, we commonly think that it is biological people, chemical people's problem, but it's not. Without the physics part, this red arrow, you cannot form it. All right, they have been arguing, that is this locally generated hypoxia, or it's because organic matter that also discharge it, or inorganic nutrient, of course, is coming from here. But how about organic matter? Well, how much is contributed? We do the observation and we do the modeling. Both of them are consistently found that 30% direct contribution to the hypoxia from this river here, discharge of organic part, not inorganic part. But it also have an indirect contribution, such as we release the nutrient, those organic matter from the river canyon. So this also gives us the good information for treatment in the upstream. Organic matter discharge, it is also important, besides the inorganic substance. Implication is that. Well, what's the consequence? Sorry. Why this figure become this? Oh, I cannot. It's damaged. Well, let me show this one is good enough. I don't know why it's damaged. What happened? What will happen? This is what we have now. Okay, pass. This is what we have now. This is a hypoxia area. HA means hypoxia area. We have about 500, 600, kilometer squares. In the future, in the next 30 years, it will double. Okay? This is a response to increase nutrient loading, in response to lower the monsoon wind, response to increase temperature. I'm sorry, I cannot show this one. I don't know why. Okay, so we have a future trends that will tell us that we need to pay attention on this. What can we do? We have a good science. We go out, we understand, we have a, to put this one in high impact journal. We tell them what is the mechanism. So what? Well, the big problem is nutrient discharge. Those nutrient discharge are coming from the big Pearl River Basin that cross the so many provinces, Guangdong, Guangxi, Yunnan, Hunan, and many provinces, Guangdong. And the major source of this nutrient dissolved in organic nitrogen is coming from the fertilizer that related to our food. You're talking about reduce the hypoxia in Hong Kong water by stopping using the fertilizer in this whole region. We got to find a better way, right? People need to eat. And people said, oh, you find all this, and what happened? What can you do? Well, we did it. At least one of the options. People in Tokyo Bay, in New York, in US, and other places are using, but we haven't done it yet. But we did it, to do this kind of study. Like we can grow the oyster. You can see those boxes. It's just this, that. Well, 10 to 200 kilometer squares of oyster. Okay, will yield the reduction of the 6 to 67% of the hypoxia volume. That's huge, which is equivalent to reducing the 10 to 60% of the river nutrient loading, which in practical, you cannot do it. You cannot do it because, as I said, we need to eat. Agriculture is important, fertilizer is important. So this is one of our mitigation scheme. And this paper we come out as quite large impact, EST journal paper now. Well, what is the impact on this study? The first thing is that I think this project that we develop a full interdisciplinary ocean research capability in Hong Kong. People say, oh, we did it, we have that. Yes, but we further develop it. We built a buoy in these three sites, 2 in Hong Kong, 1 in Hong Kong, 2 in mainland. And this kind of buoy is multidisciplinary, physical, biochemistry, and atmosphere, wind, temperature, air, so on. And I think the EPD and other government agency learned from us now, and they try to build some of them. We are the first one as this project with a very limited funding. Again, we missed one of the figure. I'm sorry that I think, I don't know why. Okay, we also conducted a repeated field survey. Okay, the cruises. We conducted cruises, I said that already. We are the most active there, not one of the most. We are most active there in the region. We get all the data from mainland sites and of course from Hong Kong side. Again, there's something not quite well. Well, we developed the modeling system. This kind of modeling system, you have hydrodynamics. Okay, I'm sorry that there's a movie here. I have 5 minutes. Hydrodynamic model, okay, and then you couple with what? Atmosphere. Well, we don't really couple it now because we're hoping that we, because the scale of this project. And you also have a river basin. We only have a stream flow now, okay, from the Hong Kong Yu Chenji. And we also have, this kind of the so-called organic matter system, and we also have agriculture system. So this is a river basin stream flow, geochemical. We also have sewage scheme, modular scheme. We have a river organic matter module, and we also have agriculture, not agriculture, I'm sorry, agriculture, aquaculture. This is oyster that we are only okay, sorry. All right. So, for example, this is a sewage discharge scheme, okay, in Hong Kong, that if you have in Victoria where they're going to go, the fate and consequence of the sewage. And you also have one in the Stonecutter, okay, this one is Stonecutter. That this kind of the system, I think the government and many of our projects here given by government have been trying to do it, including the previous systems. In last 20 years when I was in Hong Kong. But this project, we did it, okay? And this is also that we open to publics. This is our system called Wavy Ocean. You can, go there, web, app, and you can get it, those kind of hydrodynamics, okay? And biogeochemical variables, environmental variables. You can go in the intertidal, and you can also bounce the average. And if you want to do it, you can zoom in. I don't know what happened. It's computer or my PB. That you can zoom into waters in the Great Bay Area, and you can also zoom into Hong Kong. Well, we also has 3D the things. Okay, you can also look at the Hong Kong. This is the hypoxia region 3D, and you can do the surface. You can put it on together. Now you can use the app. Okay, and you search it, or you search your app of Wavy Ocean. This kind of our research has attracted attention globally and locally. Okay, we didn't expect that we have so many countries they pay attention on our project and also our local attention. Now, our web, this Wavy, now every day that you have more than 1,000 data downloads of it. Remember, this is not TikTok, okay? So hundreds is quite a lot already. And we have this kind of newspaper local coverage, the community know that. At the end, let me summarize our achievement. We have this project have been attracting attention on targeting the coastal eutrophication and hypoxia regionally and globally. Globally, there are more than 400 coastal regions suffering this kind of the problem, eutrophication and hypoxia. Our research provides science-based knowledge for mitigation and cost-effective strategy, and this is one of them now. And we hope to provide more to ensure, for example, how the artificial island can be better designed, or it's just our suggestion, okay? And to ensure sustainable water quality in HK and broader GBA. Our advanced modeling system of observational data and research finding have been the benefit the research community, government agency, stakeholder, and general public. I hope that I get quite a lot of inquiry from the government, from this audit, and actually tomorrow have similar meeting in government agency. We have advanced ocean research in Hong Kong to include the interdisciplinary physics, biological, chemical oceanography. And just for your know that HKUST, we have now the first Department of Ocean Science in Hong Kong. We link Hong Kong water to GBA. Now, Hong Kong water cannot be separated. You don't go, cyclone and then study that without pay attention on our side. Okay, that's not quite right, quite reasonable. And we advance research capability from the laboratory to institute of field measurement. And we also have a comprehensive ocean modeling capability. So that's what I said, that it is a whole spectrum. We develop this kind of capability. Of course, we have lots of work to do, modeling, and it's also another one is called digital twin. If people here that not understand what is a digital twin, the UN decades, ocean decade, the UN ocean decade is now ongoing, and this is one of our things we try to do. Well, at the end, I would like to thank the projects locally, from Hong Kong, from mainland, from international community. And with that, thank you all members for projects. And during all those years, including those, the very hard, field work before and during the COVID. And we did it amazing. Thank you very much.
Thank you very much, Professor Gang. I apologize for some of the very good effect from the slides may not be shown up, but I believe the audience will be free to approach Professor Gang for those informations in the future. Any questions from audience, please? Right, please.
Thank you, Professor Gan. I'm quite curious about oyster farming. How we are considered to use this for another purpose, for example, like carbon sequestration. And I would really like to see if this is a negative impact to the environment is very important, or is the major reason. And then we need to consider if our other technology should be developed for the future. Thank you.
Very good question. Okay, carbon power, carbon sink, or now they call it the negative carbon. Okay, it's of course important. This can also contribute to that, but this is another the topics we are actually expanding doing that. Can we grow oyster? Yes. If you go to cross the the Shenzhen Bay, okay, we have that of the Bay by Hong Kong. That you see Hong Kong side all have oyster, huge oyster. What is that oyster? Maybe clean up the water there, but recently we have many problems in coast of China that the oyster die. Is our environmental to reach a certain kind of capacity? Okay, but anyway, this is a next level's question, including the carbon. Okay, actually, I'm writing a report related to the carbon in Hong Kong water. How Hong Kong ocean, the Hong Kong water alone can be a sink of the carbon due to the this kind of the photosynthesis process and the deposition of that. But this is important. Yeah, it is.
Yeah, that's why I ask you, because I have been working with BACS, another negative emission technology. And we just published one paper for the oyster farming and for the carbon sequestration. It has been published. It has been going for 1 year. There's a lot of debate regarding it. But so I'm not working in the ocean area, so it's so important for us to really get expert view regarding the negative part, and even might be the oyster farming can be potential negative carbon emission technology, but we shouldn't have any negative other environmental impacts. So that's why
we are actually doing that entire China. I know, China total we have 2,000 kilometers square of the oyster farming. Half of them is in Shandong province. You know how many in Guangdong? Roughly 300 kilometers square. And how this area of the oyster can contribute to carbon sink and from water filtering. This is our ongoing research. Maybe we can collaborate it and
yeah, sure. Yeah, it's very interesting. Thank you.
Thank you. I'm not the oyster person, though.
Thank you, Professor Gang. Thank you for your amazing presentation. And your really commitment to speaking to a wide audience, as well as really showing us that your project doesn't just have local significance, but global significance. So appreciate it. Even though you said you're not an oyster person, my question is also about oyster, but it's kind of partly already answered by your previous response. But I wanted to ask about if indeed there's scientific evidence, of the positive implications of oyster farming. What about the economic aspect, right? If it became indeed a policy recommendation, then to do it large scale, of course, cost is a factor, and farming, after all, needs to be sustainable, both environmentally and economically. Thank you.
When we approach Deep Bay, try to do survey, those oyster farmers was hostile to us. They thought we are government people going there to find trouble to them. Okay. Economic-wise, I think if the oyster are edible, I think, of course, that we can have growth there in Deep Bay. Maybe here we can grow. But when I say that, we need to have a more cautious, because here we also have a heavy metals pollution. We need to have a more investigation. But Deep Bay, we can eat it. I don't know where the Deep Bay, maybe go to the restaurant in your Christmas dinner. But Deep Bay, we can eat it. I'm not sure that if this one is, the edible. This, as I said, this is what I mean, that not for oyster people. I need to caution. But say that there can be, the economic implication. That is huge. We only have now in Guangdong total is 300 kilometers square. Hong Kong is much smaller. And we propose there is 100 to 200 kilometers square. But government may not like it. You know why? Because oyster farming, they put it there, it looks like the beach or the offshore, the near shore, the water. Not beautiful because it's oil. Zhuhai did that. Fujian did that. So Fujian then asked their farmers to move the oyster offshore to the place where you cannot see by your, the eyes. But right away, hypoxia occurred in the bay when they move away. This is occurred in the bay in Fujian, Ningde. All right, so this is one of the evidence that we do. Well, Tokyo Bay is doing that. New York Bay, the New York Bay is also doing that. But I don't know the economic. We can do the survey. If they can be the one stone, two birds, that is great. So I think the government and academic maybe can work together and to see if we can have this kind of called aquaculture or blue economic combined with sustainable environment, build it up together. That would be great to everyone. And this is a further study or the more feasibility. The study can be conducted. Yeah. Thank you for your question.
Professor Gang, very, very glad to have your presentation on the consequence of the eutrophication. But what I heard is that most of the effort seems to have to deal with the mitigation or adaptation of the effect. But look at it, the problem comes from the discharge of nitrogen or phosphorus from the fertilizer or the farming agriculture. Is there any effort? I understand that some municipality here are trying to stop the discharge or treat the discharge from the agricultural land. Is there any effort or indication in your research that will tell them how they should treat the source? Because that is the problem. Where the problem is, you're doing all the mitigation and adaptation, which I think is not, to me here, is not the right direction. Is there any effort that coming from your researcher, you can do something here to control the discharge of this pollutant to the to the sea? Thank you.
Thank you very much for a very good question. Yes, I said that is a huge task to deal with the problem in upstream, such as fertilizer. Now, we realize this problem, and we start to study and actually ongoing big basin, river basin, fertilizer thing. This fertilizer thing, agriculture part, is not my expertise. How can increase the agriculture without increasing the using of the fertilizer? This is not my expertise. However, one thing that we can do is that we can study the deforestation, because that is the one also take up all those soil process or earth surface process. Another, urbanization. We are doing these two things now to see if we can, reduce this kind of the deforestation and also the urbanization. Because river water passing through the big river basin and the soil or surface process is so important. This is our expertise. Now, what we can do. But how can we do the agriculture part, reduce the fertilizer? I think it's a bit beyond our capability, and that's what we propose, downstream the solution rather than upstream solution. Downstream solution, we said that we can do the oyster farming, one of the solutions. Maybe seaweed, maybe other kind of the things. But seaweed, you can have affected navigation because of propeller, right? Seaweed can put into the propeller. We have a BG, the trafficker. We just started one of this, and they should have more of this. But this is a global, huge task. Thank you very much.
More questions over here?
Hi, Professor Gan. Many thanks for your very amazing and interesting talk. So my question is related to climate change. I'm not an ocean person, so we do atmospheric science and climate change, that kind of things. And my question is that, with the ongoing global warming, that so the surface temperature of the global atmosphere is going to increase. Do you expect that will have an effect on your research? Yeah.
Now, this is everyone's concern, and it's also my concern too. Let me show you your atmospheric people. Again, the PPT is not well. I think there's some. But let me tell you the one thing. We have air temperature increase. Let's record in SKO. Is our precipitation increase? Atmosphere people answer this question? Cannot. It's going to increase in the future. Atmosphere people cannot give this one. So people rely on download the CMAX 6 data, IPCC report, and it found that precipitation actually is increased. So they start to write the many papers. They never validated the lowest precipitation for the past. What we found, the CMAX prediction in our region is not right, at least for precipitation. Okay, I just have one figure there. Let it is deviated. The CMAX go this way, our data go this way, and then our future projection go this way. So our river discharge is not substantially increased or decrease in the next 30 years. I can tell you, we are writing the paper, so that I'm supposed to show you that. But climate change, regional climate change, we cannot. I also ask a community, or atmosphere people. You cannot just download the CMAX, which is hundreds of kilometers of resolution or 100 kilometers, the short one. 50 kilometers, maybe the lowest one. And you start to tell what is going to happen in Hong Kong, in GBA. As a scientist, I think we do more than that. But this is a question to you. It definitely have an increase impact. Increase the temperature, it will actually increase biological productivity, we know that. However, lower down of the monsoon wind, weaken with so-called the upwelling, and also the oceanic current, wind-driven current. And they will increase the residence time. They can also potentially increase the eutrophication. It is quite a science-based problem, comprehensively. Okay, and I also like to work with atmosphere science. I myself, we're doing the atmosphere modeling, okay? Because my undergraduate is actually atmosphere, and I also have atmosphere education. I'm a physical oceanographer, by the way. I'm not biologist. I learned from our biological colleagues, chemists call it. Otherwise, we cannot do this kind of the study. So we are have an interdisciplinary team. And right now, I also let community know that we have one of the so-called Center for Ocean Research in Hong Kong and Macau. And you are welcome to join us, and we can, also provide the collaboration and, the sponsorship for our joint research, including that the carbon part, always the carbon-related problem. Thank you very much.
All right, I think all the questions in view of time. Please join me to thank Professor Gang for a wonderful insight.